3, 2, 1.
Welcome to Talking Kotlin. Okay, so here's what happened. Suddenly, last minute, Seb decided to switch roles and tells me to do the intro, and he's doing the countdown, and I'm completely lost. I've never done this thing, right? So, welcome to Talking Kotlin. Hello, Seb. How are you?
Hi, I'm great. I love switching things up like this because now I get to see what it is like from your perspective. And I have to say, the countdown is a little easier than doing the introduction, I think.
I know it is. That's why I keep doing it year after year after year. It's been how many years now that we've been doing this? Oh God, it hasn't even been a single year. Anyway, you look very cheerful today.
Yeah, I mean, it's Advent time. Advent of Code started yesterday, so I'm a mixture between very excited and very sleepy because I get up at like 5:45 every morning now. But yeah, I've got my Christmas hat ready for more festivity. I just don't think it's very compatible with this. Yeah, I don't think it's very compatible with the headphones.
I think you look fine. I mean, it's yeah. I mean,
Doesn't make it worse, you mean?
You don't look any worse.
Oh, thanks.
Does that make you feel better?
Oh, so much.
Yeah. And so this is actually going to be our last ever episode that we record this year.
Yes.
So you decided to wear red, and I decided to shake things up a little bit and continue to wear black t-shirt, which is what I always wear to these things. In fact, that's what I wear everywhere. But anyway, enough about us. Well, we have a guest today, right?
Mm-hmm.
As opposed to every other show where we also have a guest.
That's right. Today we're sitting down with Urs Peter, who's a senior software engineer at Xavier and who's also a JetBrains certified Kotlin trainer. Hi Urs, welcome to the show.
Yes, welcome guys for this lengthy and in-depth introduction. Cool. Nice to be here with you. Looking forward.
Yeah. Yeah.
So you want me to introduce myself a bit, or
no, it's good.
With the...
Just we'll talk about that in a second. We're just in a bit of a deadlock between Hadi and me because we switched roles, so now everything's broken. Go ahead, Hadi. Why don't you take
I was
the
going
reins?
to say, where are you based, Urs?
Well, I'm based in the Netherlands, near you guys, near Amsterdam, Utrecht. That's where I'm based.
That's pretty far away from me and Seb.
Yeah,
but,
you guys is a bit So since I'm based in Munich and Hadi's based in Malaga, but close to JetBrains and at least close to a lot of the Kotlin team.
Okay, cool. I just meant that I thought that Kotlin team has moved to Amsterdam, or a big portion of it. So in that sense, close to where I am.
Yeah.
Sure.
Good thing for everybody in the world, neither Seb or I are on the Kotlin team. So,
Okay.
Yeah. Yeah, but I think we actually first met at one of the Kotlin Dev Days in Amsterdam, right?
Exactly. These ones. Yeah, the dev days.
Yeah.
So I took the opportunity today to get it out of my cupboard, because when are you going to wear these things anyway? I think, yeah, today then.
That's right. Yeah, no, I've definitely worn them a couple of times, but they're very clear in their messaging, these hoodies. There's no mistaking with the size of text that they put on there, what you are and what you do.
Exactly.
Have
Whenever I
you
give a training, this is the sweater I wear everywhere. So I'm the Kotlin guy that comes in. It's a good advertisement for people that don't do it yet.
Nice.
it's like 26 degrees in the room. No air conditioning, but I gotta wear the sweater. Like I gotta wear the hoodie.
Exactly.
I'm sweating under here, but I gotta wear the hoodie.
It's a free zone. I have to look it from that angle. Dutch people like to always save for stuff, so that's how I do it.
Dutch people like to save on stuff. Is that a thing? I did not realize that.
Yeah, definitely. You didn't? Yeah. This is kind of a sport in this country. Yeah.
I guess that's where the saying "Go Dutch" comes from. Is that
Exactly.
Is that where it comes
Exactly.
from? Yeah.
So you just don't really pay enough even for your friends.
Okay.
So that's why I actually assume they would embrace Kotlin a bit faster than they do. I mean, they do quite well because it's less lines, it's less code. But yeah, apparently They haven't gotten this yet, so
So
still
if we
still some
start
work to do.
charging for Kotlin, it's just not going to work in Holland,
Yeah,
the Netherlands, right?
I
oh,
fear not. No.
Oh, I said Holland. I'm sorry. We're going to cut that part out. Anyway, what's the topic today that we're going to discuss with yours?
Well, the topic that I've chosen together with our host is server-side Kotlin, and then especially, of course, ideally a bit advanced parts with coroutines and the like. We also can touch a bit on, definitely we'll touch on Spring Boot because if you like it or not, it's still the widest used framework out there. And maybe also can touch a little bit on Loom because I don't hear JetBrains talking a lot about it, but it's really coming. And I did my experiences with it, so I have some opinions about it. Maybe we can talk about it too.
Oh, definitely. I mean, we have covered Spring numerous times, I think, on the show, and we have covered server side as well. But we definitely want to see your angle on this. And Loom is very interesting. So maybe, in fact, we could start with Loom. What are your thoughts on Loom? And you say it's coming, and that we're not talking about it much. I don't think that's intentional, but yeah.
and maybe before that, do you want to explain to our listeners what is Loom?
Well,
Okay.
I was assuming that's going to happen, Seb, but okay, thank you very much. Yes.
Oh, thank you for telling. I really wouldn't, would have totally forgotten that. Well, what is Loom? It's Project Loom. It's probably the project that has been longest around ever in the Java community. Already for years they're talking about Loom, and it never arrived. But until this September, they announced it as a preview feature in Java 19. So actually now is really the moment where stuff is getting serious. Then you still don't know what Loom is. Well, actually, in a nutshell, Loom is coroutines embedded in the JVM. So not on the language level, but on JVM level. And what you'll see in Loom is they kind of really copy paste a lot of stuff out of coroutines. I mean, all the concepts that are there, and we can talk about them maybe later on more in detail. They kind of ported them and, well, put them in the JVM. And the way they did this is also very interesting. There were quite some iterations going through it. So they had different kind of names also. They talked about green threads. They talked about fibers. Eventually, they became virtual threads. And well, the approach they did is kind of interesting. So that's for the introduction. I can talk a lot more about it, but maybe that's for the introduction. So what you basically get then, maybe that's a good thing to add. What you should get on JVM is that without any kind of additional abstraction, I mean, with coroutines, you have a minimal amount of abstraction. You only have the suspend keyword, so to say. That's abstraction that's introduced, the builders. And when you have Loom, then actually without any abstraction, you get the same performance out of your application. So basically, non-blocking I/O as if it is blocking in your code, but it's non-block as long as it runs on this virtual thread.
So essentially, we're kind of getting native JVM support for what coroutines did for a couple of years now. Would that be a way of saying it?
That's exactly a way of saying it. And in that sense, also, I think it's good to emphasize that Kotlin is only a host language, right? So the Kotlin doesn't own the JVM. So the approach Kotlin has chosen is basically the only approach they could have chosen because they cannot influence the JVM by themselves. And now actually Java went more a bit the Go route. Go did more or less the same. So they embedded this whole latency behavior into the JVM itself. And that's only something Java can do. That's not something we could do.
But of course, so Java has its existing abstractions, right? So you have threads, for example, that just or thread pools that all, at least on some level, map directly to your system threads. Are those abstractions staying the same with Project Loom, or are they introducing like something new there? Do people have to change the mental model if they come from the Java or from the Kotlin world?
That's a very good question. And as I said, I kind of really followed the whole design process of Loom. And well, they made a decision which is quite funny in the sense that most probably we as Kotlin developers will profit way more from it than Java does. It's kind of paradox, right? So what they did is, first of all, they tried to come up with some sort of new kind of thread. But then they said, yeah, we want to stay backwards compatible, and all the Java people, how are they going to kind of absorb that? Because you don't want to have the same, like with all this reactive stuff, it's only actually tools for specialists. I mean, when you go to an average project and you say we use reactive, then they look at you like that, and maybe one or two guys think they know what they're doing and they still don't know what they're doing. So this is actually how reactive turns out to be used in the world, at least what I see around me, and I come to quite some environments. So I dare to say this is a bit of the average. So what the Java people said, okay, so let's not introduce a new abstraction. Just reuse the interface of thread. That's basically what they did. So they have, instead of the normal threads, and as you say, they're normally kind of connected to the OS threads. So they introduced the same thing, the same thread interface, but then it's called virtual thread. And virtual thread is really the same like a coroutine. And virtual threads, of course, also need some real thread to be executed. That's what they call a carrier thread in Java. So thread pools is just not needed anymore. Pools you always need if reads are expensive, right? In coroutines, you don't have coroutine pools. Why? Because they're cheap. So thread pools will actually also disappear in Java in the sense when you have at least virtual threads. You just can get new virtual threads as you can get new coroutines. And this choice kind of is interesting because it's true. I mean, it's not invasive, so you have the same abstraction, but depending on which thread you run, if you do blocking stuff, it will really block on a normal thread. But if you have a virtual thread and you really don't know, unless you really kind of say current thread instance of virtual thread, then you know that use a virtual thread, then stuff just behaves as in coroutines, nicely non-blocking.
Okay, so is this the part where you said that Kotlin developers might be profiting more from this than Java developers, specifically because of this little like making this distinction? Like if your code is already engineered towards using coroutines, then you know it's not gonna block your underlying thread. I would assume, whereas you probably don't have that with legacy Java code.
Yeah, so that's not really, I think, where the confusion will be resolved in Kotlin. The point is when you do this kind of virtual green, whatever thread you call it, fiber stuff, then you have some things to take care of. And one of the things, for instance, is context propagation, right? So all these server containers, they work with this thread local concept that some sort of context go through a whole call chain. And when you have a single thread, that's easy. You just can lift on the thread you're using to execute the thing. But when you have multiple threads, that's kind of an issue. And coroutines nicely solve this. So you can, of course, pass context, and then it will be nicely propagated through all the coroutines. And in Java, because they don't have these function literal receivers, these kind of, that's the word Kotlin uses. Maybe I have a better word for people to understand. These are these kind of code blocks like coroutine scope, and then you have a code block where you get some context in it, for instance, the coroutine scope. These constructs are lacking in Java. So what Java came up with, they also have some sort of way to propagate your data across a whole call chain that involves many virtual threads. But these APIs are just really, really horrible to use. That's really just, ugh. But Kotlin, because we have this abstraction, we can make this kind of hide away. We simply could say, instead of coroutine scope, we could say virtual scope. And then you have all the scoping in need where you could say, okay, this is a kind of block that needs to make use of the structure concurrency. So this is one big advantage you have. A second is, which is really kind of, extremely confusing for Java people. You might know the evolution of future. Do you know the evolution of future in Java? I'm the
Repeat
old
it
guy with
for
the gray
us.
hair.
Yeah, I think it would make sense to repeat it in any case. Give a quick
Yeah.
summary for our listeners.
Okay, so I think in, I don't know, 1.7, something like that, Java, don't pin me on that, but definitely before 1.8, they had a future abstraction. Well, it's a future abstraction models latency, so you can have a task that executes, and once you get a reply back, then normally you would expect a function to be triggered. It's sort of a callback, but then in a more structural way than just passing some function that is executed once you get there. You get really something back of a future. once a result has been computed. The first feature Java implemented is really ridiculous. They made it blocking. So you could indeed execute the second task in some other thread, but when you waited for the result, you had to block this future. So you always had two threads just kind of wasted. Okay, so that was 1.7. Then people started to think they saw. I think Scala also had a big influence on them because Scala did futures in a neat way. And then it came when 1.8 it came with the completable future. And I think this was more or less the first abstraction that was kind of a decent reactive approach, except that it was way over the top and very complicated to use. And there you got the nice bit. You got the map or the flat map, right? So map would be called once the result is there, and then you would get another completable future, and then you would stay in this complete future change with the monadic kind of approach that actually all the reactive frameworks use. And then you have all the other toolkits like Spring as Webflux, Mono, and so on. Now back to Loom, right? How do you model parallel behavior in Loom? In coroutines, we have async await, right? We can or launch. You can launch different coroutines, and then you get parallel behavior, or you can say async and eventually await, and then get results back. This is how we do it in coroutines. In Loom, this is something you need an abstraction for. You cannot just say these statements go parallel. I mean, you somehow have to tell the language, I want to execute something in parallel. So what they did is, because now when you block something, like for instance the Java 1.7 future where it did a blocking get for the value, is bad for real threads, but for virtual threads it's not bad because it doesn't block. So now when you have a virtual thread and you use the old Java future from 1.7, it's perfectly fine. That's what they also give you in the example. So you don't need to use this kind of completable futures where you stay in this horrible call chains where you get this nested kind of code instead of the sequential code. So actually they kind of tell you, hey, go use these old futures from 1.7 in order to achieve parallel behavior. But how are you going to explain to someone who's not really into deep into this reactive stuff that depending on your thread, this is good or this is bad? I think confusion is perfect. And in Kotlin, yeah, sorry.
Yeah, I was going to say confusion. That's a good place to maybe talk about confusion, right? Because what I'm hearing quite a bit is that, and correct me if I'm wrong here, that the abstractions, the implementation of Loom is lower down so that many things don't change. But and maybe this will impact things in a positive way in terms of performance. But coroutines wasn't only about performance; it's also about finding an easier programming model, something that reactive, RX Java, and maybe threading wasn't really the easiest way to handle these kinds of applications. Do you think that Project Loom addresses this in any way? Because
Yeah,
by the sounds
definitely.
of it, it doesn't.
Yeah, definitely does. It does. So indeed, you might get the impression because I said they only kind of change the thread. That's it. That's not entirely true. They still have means to make structure concurrency work as it works in Kotlin Coroutines. So what you use in Java, you use the try with resource block. So within try with resource blocks, these are kind of boundaries for structure concurrency.
The
And they
same
also have some,
construct, try with resource.
yeah. So then you would have some executor, and you say, give me the executor, and this execute, then you can execute stuff, and this would then be the granularity you have where you get this kind of clear boundaries. First, complete that before you continue something else. So they baked in with kind of existing Java constructs. They baked this into Loom. And I said it's confusing, right? Because it's just existing constructs that get a total different meaning, and I'm curious whether people are going to understand it. Whereas in Kotlin, you can kind of keep this kind of more or less the same abstraction that we have with coroutines. For instance, for async await, you still can make some async await. When you have this kind of virtual context instead of Kotlin context, you could make an async method on it, and then instead of you could get back such a future, but you would then, for instance, use an await on this future. Then you have more or less the same paradigm. For Kotlin developers, it would kind of be a seamless switch. Whereas for Java developers, said I'm really pressing thumbs that they will kind of manage that, or move over to Kotlin, of course.
So your prediction in this case would be that the coroutines APIs as they are now uh, can just make use of Loom when it arrives. Like it essentially is just kind of it makes the engine under the hood a little less complicated. We need to do less like transformations and stuff. But as an application developer, the mental concepts that I've spent a bunch of time learning over the last few years, those will still apply the same. Is that what I'm hearing?
Yeah, it's a very good question, because that's also a bit something I'm curious about how the Kotlin team is thinking of that, because you have different options. The nice thing about Loom is that it's truly non-invasive. In Kotlin, once you suspend, then it's kind of viral all over. I mean, you still get nice signatures, so that's a really big benefit. But still, and in the beginning of a call chain, you somehow need to provide this context. With virtual threads, when you just use a virtual thread factory that gives you all the time a new virtual thread, you just can start with virtual thread everywhere, right? So this is already a big advantage. So which you get to the actual two options. So first, you could only use virtual threads and then provide some new kind of builder methods with virtual scope, async await, only for virtual threads, so not doing it with coroutines at all. Maybe a simple library, I thought already about it. Maybe you could write it just to get a bit of feeling how this would look like. I think you would get far, except of course for flow. You still need abstraction that models values over time. This is not in the threading yet. So you need something like that, if you like it or not. Also, the Java implementation needs to have such an abstraction. So that is one choice. The other would be that you say, okay, we just stay within coroutines and use virtual thread instead of coroutine. Probably it's not very smart to use coroutines on top of virtual thread, because then you have two lightweight implementations on top of each other. I think, yeah, you could probably get it more performant if you kind of would iron that out. But this is something for also the language designer to maybe also make it agnostic, that when you have a virtual thread, they kind of skip their own coroutines, but then use, yeah, the virtual thread instead. But that's something that Kotlin could provide.
Yeah,
So there, I'm also a bit, yeah, I'm curious. I'm curious how this will be kind of implemented. But just as a summary, it would be really cool that you don't need to suspend anymore, and you just have this behavior in Kotlin.
Okay. Yeah, I mean, possibly the whole kind of switch from like state machines, how coroutines are implemented currently, to just going for virtual threads with Loom. Maybe that's even something the compiler can somehow provide. If we have someone like Roman Yelizarov or someone from the coroutines team on the show again, I think this is a question we might need to keep in our back pocket.
Yeah, that would be cool. Yeah. So I'm also really curious, and following this, for me, I said, let's be honest, I mean, this is really hardcore. Recording implementation is, I mean, I looked at it, this is just hardcore. Probably also a lot of testing to see whether really don't get any kind of leak or unexpected behavior. So yeah, this I would really leave up to the pro and not to myself. The happy few of this world that can handle this kind of complexity. Yeah.
Oh yeah.
So for the rest of us, how would I say, non-advanced folks, or at least me, how does this affect me as a Kotlin developer that is used to using coroutines? Should I be looking at other options, or can I continue safely down the path of coroutines, or what?
Yeah, so I might now say something a bit unorthodox. Don't know if you like it, but
You
that's
can
what
say
I
whatever
say.
you want.
Oh,
We'll
cool,
cut it
cool.
out later if we don't agree.
Exactly,
So
exactly.
it's fine.
So first of all, coroutines are definitely here to stay, because on Android there is no Loom, right? So and also on the native there is no Loom.
Yeah, it's not
So
multi-platform.
exactly. So coroutines are here to stay, but server-side GVM, that might be a different story. So what I tell people is, if your application performance is not so crucial and your resource usage is not really crucial, you spin just up another container. Why do all the hassle and use this reactive stuff? That's what they say, because when Loom eventually arrives, at least all the I/O and everything will automatically get better in terms of resource usage and so on. So you will get your performance kind of boost automatically over time. And if you now can live with it, don't just burn yourself with all the complexity of using coroutines. So this is actually what I say the default. If you have really a business case, and I've written, of course, applications that have a business case that need this low latency, but also manageability in terms of maintenance of your code needed now, reactive drivers and so on, then I definitely advise them always use coroutines. Never use a reactive toolkit. Why? Because should Loom arrive, it's so much easier to rewrite your coroutine applications in case it doesn't make sense anymore to a Loom style than just throw out all the monos and all these abstractions that you put into there. That's kind of full rewrite you get when you move from reactive code bases to Loom. That's rewrite. So coroutine, I think, if you need it now, is the best choice you can do. And if you don't need it, don't do it. Loom will kind of fix it for you over time. That's my recipe.
All right, so let's. I think this is a good segue because you already mentioned kind of server load and in general like server side projects here. So what are kind of the incumbents? What are people currently using where you are telling them move over to coroutines? I mean, RX Java is I guess the obvious one, but I guess there's more.
Yeah, definitely. So actually, RX Java is not used often server side because there is no big framework supporting it very well. So if you look at Spring Boot, they use Reactor. They have these monos and fluxes. When you look at Quarkus, they use their own abstractions, a Uni and something else. They all invent same names over and over again just to make it really hard to step over. And I think Micronaut, yeah, I don't know for sure. I think they might use RX Java. That's possible. Yeah, I've looked at how they do coroutines, but not at how they do reactive by themselves. So these are a bit the three flavors you have. And I said in all flavors, it's so silly to use their own abstractions because Uni is really not the same like a Mono is not the same like RX Java. It's just the implementation details, they are quite different. And you get actually more or less relearn a whole new framework again. Whereas if you use coroutines that just abstract all these mess away, well, then you can much easier switch from one framework to the other. So if you're a framework hopper, it's even, and you want to use reactive
framework hopper.
Yeah, nowadays you have all kind of people. Yeah.
Yeah, I mean, it does seem like a pretty easy win in this regard. If the option is getting a bunch of different ones or having one that's kind of vendor independent as an abstraction, it's
Exactly.
yeah. I guess it just allows you to switch much easier.
Yeah.
So I think one of the big points that like if you want to do a direct comparison between reactive frameworks and kind of coroutines, one of the things that often gets discussed as well is Kotlin Flows, right? So how do those fit into like the overall puzzle?
Yeah, I had the pleasure to write streaming APIs in Spring Boot with server-sent events. And yeah, first I've written them in Scala. There's a lot to say about Scala. It's really complex, but it also really works well. We didn't do this in Kotlin yet because it was still experimental, and we also had initially some issues. Now they're ironed out, so I think now I would say give it a go because the code was getting way simpler when you use Flow instead of the Scala stuff. So this is legacy by now. Yeah, I personally like Flow way better than the reactive counterparts. And for instance, that's what I've written in Spring Boot with fluxes. Then you don't have the monos. Mono is actually single value. Fluxes is multiple values over time. Fluxos is just a terrible abstraction to work with. It's kind of this blueprint you give with all kind of things that might happen. And then you kind of hope and pray that it behaves as you want. And if it doesn't, then you really scratch your head many times. And Flow is kind of, you can almost see the code go through it. And of course, it also aligns nicely with other suspend functions. What's also really cool about Flow is that, for instance, also for GDBC, you can turn GDBC into Flow. this blocking flow extension they have. That's also what they use because Oracle, they say they have reactive toolkit, but they don't. So there we had to use the GDBC driver instead of the reactive R2DBC driver. And with these kind of tools, we got it really easily hooked into Flow.
So you're just kind of building this abstraction yourself, or do the frameworks already provide this integration between, for example, GDBC and your flows?
No, these frameworks don't provide. You have to write yourself, but it's really easy because you have some sort of blocking helper method available in Flow that tells, okay, here you just can do some blocking code, then you have some callbacks to implement. So it's maybe 20 lines of code. Of course, it's a bit complex code, but it's quite well done. And the nice thing about Flux, for instance, is you simply can convert it to Flow. So the reactor extensions of Kotlin X, they all have these conversions that you can easily convert them. So that's what immediately did, because yeah, underneath it's still, of course, Reactor, what we're using. But to make it manageable, yeah, with either coroutines or Flow. And then it was really a piece of cake to implement it.
So even when you have kind of some APIs that are already out there or that you're relying on that are using Reactor, it's pretty easy to just plug yourself in, use the same concepts that you know with Flow. Is that what I'm hearing?
Yeah. Same for Kafka. Many people have to use Reactor for Kafka because that's also a widely used thing in enterprise. And there also you simply say Flux to Flow, and then you kind of, oh yeah, I get it again. I'm really think I think that they did this so fantastically in Kotlin. I really have to praise you guys. That first of all you provide coroutines, which is a very sane and decent abstraction, but then you also provide tools to kind of leverage all kind of asynchronous constructs with simply one method to this new universe. This is just fantastic.
Yeah,
really
while we're not on the Kotlin team, all of the compliments we will accept. Thank you.
Okay.
So you speak a lot about Spring, and I guess you have a lot of experience with Spring. But when it comes to server-side frameworks and you being out there in the field, providing training and consulting for folks, what are the main ones that people are using with Kotlin, other than Spring Boot?
Yeah, so that's an interesting, a very good question. Very good question. So maybe first, why I'm not really particularly a fan of Spring. Just to face, I've used many others, also very complex ones like Akka. Good luck with Akka and all the CQRS event sourcing stuff that you get there. Um, what's interesting about Spring is that it's most widely used. And if it's most widely used, then when people step over from Java to Kotlin, they only have to learn a new language. And if you have to learn both, that's quite a thing. For Java Labs, it's already quite a big hop to learn a new language, but then also learn a total new framework that, let's be honest, in the end, they more or less do the same, just in a different way. I haven't really seen this particular framework that does something way more better. I will talk about it in a minute. There are some things that might be interesting in others, but in the end, even if you use Skater or Spring, they achieve more or less the same result. It's different means. So that's why I'm actually also really a kind of don't push people at all to, for instance, go to something else. Just use what you used, but use it with Kotlin. That already gives you so much more benefit.
And also when you want to
what?
And with coroutines, I guess, not just with Kotlin.
Of course. Yes, of course. With Spring Boot, and then yeah, the sensible way with coroutines. So this is for actually the Java people that move over to Kotlin. We just we made acquisition recently with 47. You might know the guys behind Arrow. They do a lot of functional programming stuff, and it's interesting to see they have a bit of different customer base. We are targeting a bit because we are big GVM people, so we'll target our GVM market, but they are more targeting the kind of functional market, functional programming market. And there you see sometimes companies stepping over from total different ecosystem to Kotlin. And there, it's actually also a good idea, I would say, to start with Keter, because this is really native to Kotlin. It is coroutines by default, no abstraction on top of it, and so on. So there, I think Keter is a perfect fit. So my point is, it's not good or bad. It's highly contextual. And in terms of the other frames of Spring Boot, what Spring Boot does particularly bad nowadays is the whole native stuff. Spring Boot really relies on this class path scanning, reflection, and native is really getting big, also in the Java world. I don't know if you're aware of that. Just went to conference. I'm quite surprised. This kind of make containers spin up instantly has become a real necessity.
So this is the whole idea of Graal native image, that kind of stuff.
Exactly. Exactly. Yeah. This is really taking a tremendous flight right now because you have serverless kind of architectures and a GVM starting up. GVM is nice if it runs and after 10,000 calls you get the optimization. This is where GVM kind of shines, but not with fast startup. It's just horrible. We also had the same, we used some lambdas. We written them in Python till now because yeah, having in Kotlin GVM doesn't work. Yeah, Kotlin GS, but that wasn't in terms of frameworks. But now with GraalVM, we just had we had a working example. That kind of is a sweet spot. So Spring Boot does this particularly bad because it was not designed for that. So now they really try to make this work. And Spring.3, the focus is really on native. Quarkus, for instance, was I think more one of the first. They kind of made it very easy to run on the GraalVM. And Micronaut too, because Micronaut wanted actually to have all these dependency injection at compile time rather than runtime. So Micronaut is also redesigned to have larger startup times.
Mm. Yeah, I think if I recall correctly, and you can correct me here, Hadi, I believe that the Ktor also, it both has GraalVM support with like native image, and it also just goes straight for Kotlin native without the JVM abstraction.
Correct. Yeah. Both.
Yeah.
Yep. On server side, yes. The server side Kotlin, and not native side. Sorry, client side has already been there for a while, but the server side, which is the one that we recently, no, I was like earlier this year. Well, we did Kotlin native support.
Last September, right? Then the new memory model was announced. I think that was a kind of a key for Kotlin to really move forward on the native side.
Well, we had support for Kotlin native in Ktor very early this year, even before the new memory model. We've got folks using both via Graal as well as directly via Kotlin native
at the same time.
Yeah.
At the same time, and they've got JVM in the background, and they've got a fail-safe option of if all else fails, you've always got Node.js.
Okay. Yeah, I'm also quite interested in how this development is going because, as you say, you have native or you have Graal. The nice of Graal, of course, that you can use most of the stuff that Java has produced. And native, this is a library issue, right? It's also a chicken egg problem, I guess. If you don't have a lot of libraries, people won't use it, and how are we going to solve that? So I'm also really curious how this is going to develop. So I keep really.
Well, I mean, that's a general problem with Kotlin. General problem. It's a thing that affects everything in terms of multi-platform with Kotlin. But it's surprising that what I found is, so there's a bunch of libraries that the libraries team at JetBrains are working on. Some what we could consider core libraries, but there's already tons of other libraries out there that are multi-platform, and every time I look, I discover more things, and then it feels like now it's become a myth in a sense, right? That there's no Kotlin multi-platform libraries. Well, actually, there is. The other aspect is how can we try and make this more discoverable, which is something we're working on from the Kotlin side, from JetBrains side to address that in a way.
Yeah, that's cool. That's good to hear. Because I think also it's kind of a nice thing for developers to port stuff from one platform to the other. Some people consider this a lot of sport, right? So eventually this stuff will appear, or has already appeared. Yeah, discoverability is key then. Yeah.
So cool. I think we've clearly seen today that there's a lot of stuff to look forward to, and that a lot of stuff is really manifesting from kind of what used to be ideas and promises a while ago, and now with Loom being in preview in Java 17, as you said, and with all the functionality and adoption of Kotlin and coroutines on the server side, as well as kind of the growth of native stuff. So I'm definitely looking forward to seeing what's next. Yeah. But unfortunately, for today, we are gonna be out of time. So I want to say thank you so much, Urs, for coming on the show. I've checked beforehand, and I know that people can find a couple of your talks on YouTube as well, just by looking up your name. So it's just Urs Peter. But is there anything else that you would like to like shout out, where people can maybe follow you or you want to draw attention to?
I will write a kind of lengthier series about Spring Boot and coroutines because first of all, Spring Boot hasn't done its homework fully yet. There's still some pull requests you should do. Security is not yet working very well. There's some other kind of key areas that you have to do some custom stuff to make it work. So there could definitely be done something more. So watch out for these. And for the rest, I'm also talking at the Kotlin Conf. We also give a workshop there. Yeah, see you around.
Great. Well, it was wonderful having you on the show, Urs, and
Thanks
yep, we'll
too.
see you at some point soon.
Yes,
Yeah,
it was a pleasure and
definitely
an
at Kotlin
honor.
Conf. All right.
Take care.
Yes, cool.
Take care,
Thanks,
everyone.
guys. Bye bye.
All right. Bye bye.